Hello! Today in class we're going to solve examples in which we will apply the properties of powers. The first example, we need to find the value of the following expression. R to the power of 18 times A to the power of 19 divided by A to the power of 17 times A to the power of 19. We need to find the value of this expression if A is 2.8. In order to find the value of this expression, we need to substitute 2.8 for the variable A. But if instead of A we substitute 2.8 to the 18th power multiplied by 2.8 to the 19th power divided by 2.8 to the 17th power and multiply by 2.8 to the 19th degree. In order to solve this example, we won't put 2.8 to degree 18, 19, 17 and again 19. Rather, we will apply our property. In the numerator, we will apply the first property. What do we need to do this? Let's pay attention to the base. These are the same numbers, so we'll use our first property and write down 2.8. And add 19 to 18 plus 19. In the denominator, we also have a product and then we also use the first property. The result is 2.8 to the power of 17 plus 19. In the numerator, 18 plus 19 is degree 37. And in the denominator, we have degree 36. And then, in order to calculate the value of this fractional number, we'll use the second property. And then we'll subtract 36 from 37. So 2.8 to the power of 37 minus 36. And the result is 2.8 to the power of 1. And 2.8 to the power of 1 is 2.8. We solved this example by applying the properties of powers. But I'd like to point out and write down another important property. Notice our answer. 2.8 to the power of 1. The degree is equal to 1. If the degree of any number is equal to 1, then we write the same number in our answer. Therefore, I can add another property. If I raise any number to the first degree, the result is the same number. Why is this property a very important property in math? Because when we apply properties 1, 2, 3, and so on, we can get the answer wrong when solving an example. Let's solve the following example. And in it, a to the power of 3, I need to multiply by a to the power of 4 and multiply by a. In order to solve this example and simplify the expression, we'll use the first property because the bases are the same, by rule of thumb. I have to write the base of the degree unchanged and add the exponents. Now, 3 plus 4 and the last multiplier. The degree is not written down, but if there is no degree, the degree is not written down, then it is the first degree. And then I have to add 4 to 3 and add 1. That equals, and the degree is 8. We used our properties to solve this example. Let's check to see. Are we correct in determining the degree of the third multiplier? Does it really have a degree equal to 1? If we use the definition of the degree of a number, then a to the power of 3 is a times a times a times a. That's a to the power of 3, and a to the power of 4 is a times a times a times a times a times a times a. 4 times, 3 times, 4 times. We're also going to write down another multiplier that equals a third multiplier. Now let's count how many multipliers of a we have. 1, 2, 3, 4, 5, 6, 7, 8. The result is a to the 8th power. Now, if you see a variable in an example that doesn't have a degree written down, that degree is always 1. Use this property and you will always get the correct answer. In the next lesson, we will continue solving examples using our properties, and for today, our lesson has come to an end. Goodbye. See you again.